Okay, so let's go ahead and take a look at all the odd numbered questions. So what we're going to do is we're going to simplify. And again, when in doubt, change everything to sines and cosines. So I'm going to change tangent into sine of theta over cosine of theta. And then I'm multiplying by cosine of theta, which is technically over 1. And then my cosines cancel out, and I'm left with sine of theta. Okay. Odd numbered questions again. So cosecant is the same thing as 1 over sine. And I'm multiplying by sine of theta, which is technically over 1. My sines cancel out, and I'm left with 1. Going to question 5, I have sine of theta. Cotangent is cosine of theta over sine of theta. And you do need to memorize this stuff. So then you get cosine of theta as your answer because your sines cancel out. Okay. So again, like the reason why I can go through this really quickly is because I know all of my identities, right? So I know, cosecant is the same thing as 1 over sine, cotangent is cosine over sine. And so the faster that you guys can memorize those, the better off you're going to be. So what I would do if it was me is I would go through and I would make some flashcards. Okay, so cosine of theta, and then I have 1 over cosine of theta. And again, my cosines cancel out, and I'm left with 1. Going to 9, tangent squared is the same thing as sine squared theta over cosine squared theta. Cosecant is the same thing as 1 over sine of theta, and cotangent is the same thing as cosine theta over sine of theta. I have 2 sine of thetas down in my denominator, 2 of them in my numerator. I have 1 cosine in my numerator and 2 of them in my denominator, so one of them can go away, and I'm left with 1 over cosine of theta, which is secant of theta. Okay, question number 11. Ooh, getting a little bit more complicated. Okay, so let's go with our tangent squared is sine squared theta over cosine squared theta. My cotangent is cosine theta over sine of theta. And this is all divided by my square root of sine of theta over 1. And then 1 over cosecant. So this is 1 over sine of theta. Okay, so now we got to do some simplifying here. I'm going to reduce here my cosine here and 1 of my cosines, and then 1 of my sines and 1 of my sines. So my numerator, I'll be left with a sine of theta and a cosine of theta. In my denominator, I'm going to turn around, I'm going to invert and multiply my denominator. So I have my sine of theta over 1, and then I have sine of theta over 1. So now, draw my little arrow over here. So I have sine of theta in my numerator over cosine of theta. And then I have the square root of sine squared of theta. So the square root of a squared just gets rid of one of them. So I have sine of theta over cosine of theta divided by sine of theta over 1. Now I can take my denominator here and I can invert and multiply. So I have sine of theta, cosine of theta, 1 over sine of theta, and magic happens. Sines of thetas go away. I'm left with 1 over cosine of theta, and 1 over cosine is secant. So I did all that work, and I get secant of theta. All right, 12 is an even. We go to 13. 13, the first thing I think of is, man, that looks like a Pythagorean identity. So remember that 1 plus tangent squared of theta is secant squared of theta. So I would have changed my numerator to secant squared of theta over cosecant squared of theta. Then I would probably have changed my secant into 1 over cosine squared, and then my cosecant to 1 over sine squared. I take my denominator, I invert and multiply, so I have cosine squared of theta times sine squared of theta over 1. So I get sine squared theta over cosine squared theta. And then sine squared over cosine squared is tangent squared of theta. So I get tangent squared theta. Okay, 14 is an even. Let's see, 15. Oh, look, they have a greatest common factor. just when you thought you didn't have to factor anymore. So I can pull out a cosine of x. So I pull out a cosine of x. I'm left with a 1 minus, just kidding, cosine squared of x. Remember that 1 minus cosine squared of x is equal to sine squared of x. So this is cosine of x times sine squared of x. All right, 16 isn't even. Jump to 17. Ooh, getting a little bit tricky. Okay, so, you know, they're not squared, so you can't really do any identities. Really, at this point, to try to simplify this, the only thing I can think about doing is changing everybody into sines and cosines. So I have 1 plus sine of x over cosine of x. And this 1 is over 1. That is my numerator. Divided by my denominator here, which is 1 over 1 plus cosine of x over sine of x. So now I'm going to find a common denominator in my numerator. So I have a cosine of x over cosine of x plus sine of x over cosine of x. And then my denominator will be a sine of x over sine of x plus cosine of x over sine of x. Now I can combine my numerator into one fraction. So I have cosine of x plus sine of x over cosine of x. And then my denominator is sine of x plus cosine of x over sine of x. Man, a lot of sines and cosines. So now I'm going to write my numerator, cosine of x plus sine of x over cosine of x. And then I'm going to invert and multiply my denominator here. So that gives me a sine in the numerator by itself, and then a sine of x plus cosine of x. When you have the same thing, so I have a cosine plus sine and a sine plus cosine, because they're both positive in the middle, everybody's positive, they are the exact same thing. So I could have rewritten either one of them like the other and it would have been fine. So they both cancel out, and I'm left with a sine of x over cosine of x, which is tangent of x. This situation here only works when everybody's positive. If somebody's negative, both of them are negative, both of them are negative, it's still the same thing as both of them being positive. But if one of them is negative, it does not work to cancel out unless you multiply or you factor out a -1. So the only reason why this works is because they're both positive. If they were both negative, it would work the same way, but that's the only reason why I can cancel out. Okay, and then 18 is an even, 19. Let's see, so sine squared, so first of all, sine squared plus cosine squared, that is equal to 1. And then we had that 1 plus tangent squared, wrote my x funny, is equal to secant squared. So then the secant squared minus tangent squared is equal to 1, so the whole thing is equal to 1. Okay, and then there's 20, and then there's 21. So 21 sine of x, cosine of x, sine of x over cosine of x, which is tangent. Secant is 1 over cosine of x, and cosecant is 1 over sine. So actually, I didn't really need to change my tangent here because my sines and my cosines and my numerator and denominator cancel out, and I'm left with a tangent of x. Okay, and that is it for all the odd ones.